What's good, everyone? Today we're going to go over that topic and we're going to use that example. And as always, make sure that you pay attention in class, pay attention to your teacher. If you don't understand what they're talking about, you can always come here and take a look at this topic. Before I show you guys how to simplify square roots, as always, I always want to have these sort of reminders. This way, it's easier for me to lead you into how to simplify the square roots. Remember that when it comes to square roots, what we want to do is we want pairs under the square root. The reason we want pairs is that the square root is going to cancel with the square, right? They're basically opposite operations. You take a square root of a square, you'll end up with just the value that you're squaring. So we always want pairs under the square root. It will then help you resolve the square root and the square. Another concept here that you should remember is that whenever you have numbers being multiplied under the square root, you can always separate those into separate square root like this. Or you can go vice versa. You can also go the other way as well. So if you have three separate square roots all being multiplied together, you can then combine them into one group under the square root. Okay, now with all that said, let's see what we can do with the 48, square root of 48 here. So the first thing you want to do whenever you have a square root of 48, and again, this is one way that I find to be the most helpful in doing square root. It is also the easiest way. There are, of course, another way to do this as well. In math, typically you have a couple ways to do certain things, not just one way. But this is the easiest way I know how. So the first thing I would do is I just break 48 into factors. Basically, this is called prime factorization. You're basically breaking 48 into prime numbers. Anytime you see a prime number, you would stop. So for me, I just think of a quick pair of factors for 48. So for example, I can do something like 12 times 4. If it is a prime number, I'll stop and I'll underline it to keep track of it. But if it's not a prime number, then I keep breaking it down. So 4 is not a prime number, so I cross it out and I know that it will become 2 times 2. In this case, I know 2 is a prime number and that 2 is also a prime number, so I'll keep it. I'm not going to go any further. Here for 12, I can then break it down to a 3, and I know 3 is a prime number, so I'll stop. Here 4 is not, so again I'll cross it out and I'll break down 4 is 2 times 2. And those I know are prime numbers. So in this case, I know that square root of 48 is the same thing as saying, and remember I want this in terms of pairs. So I have one pair of 2's here, so I write 2 squared. Then I have another pair of 2 here, so then I'll write multiplied by another 2 squared. That's gone. Now I have the 3 left. 3 is not in pairs, so I will just write 3 to the power of 1 or just 3. Now in this case, then I can write, remember that the laws, the square root law said that we can then break each of these into separate square roots. So then we go square root of 2 squared times square root of 2 squared times square root of 3. Then I would open a parenthesis up, and if something cannot be simplified or they don't have a pair, then you cannot simplify it. So for example here, I know that there are a pair of 2's and it's being square rooted. So then I can cancel the square root and the 2, so that will leave me with just one 2 that is outside. The same can be done for this square root. So then I would take a 2 and multiply by another 2, and that 2 came from that expression. As you can see here, the square root of 3 is just by its lonesome self, so I cannot simplify that. That will have to go into the square root. Therefore, in this case, my final answer would be 2 times 2 is 4, square root of 3. Okay, Now next, let's try the square root of 90. I will do the same process. Take square root of 90, and I will take the prime factorization. In this case, it would just be 9 times 10. And I know that 9 is not a prime number, so I cross it out, and I put 3 times 3. So those are prime number. I will keep them. 10, same thing. I can't keep that, but I can certainly break it down to 2 times 5, and both of those are prime numbers. So then, here again, I want to collect pairs of them. Square root of 3 squared times 2, and there's no pair for 2, so I just have to write 2. And same thing with 5, there's no pairs for 5, so I would just have to write 5. Now again, we want to split that into separate square roots, so it's easy to manage and see. Square root of 2 times square root of 5. So then in this case, as you can see here, we have a square and a square root. So then we'll open a big square like that. Here we have that is 3 squared. So obviously we can take out one single 2 because that 2 and that square root will cancel each other out. So we have a 3 here. And then here, this we can say is the same thing as square root of 2 times 5. Remember that we can also go backwards. We have 2 separate square root and they're just multiplying by each other. We can combine the number and put them in one single square root. And in this case, I know that there's nothing I can do with the 2 and the 5. Since they're single by themselves, I can't really pull it out of the square root. Therefore, I have to keep it inside the square root. So the answer in this case should be 3 root 10. Okay. Hopefully that was clear. Any questions, feel free to leave a comment below and I will take a look and I will answer you directly. Thanks for watching.